next up we have a no cool call. The customer states that the heating worked just fine yesterday. They switched over to air conditioning mode this afternoon. After a few hours, noticed it was still blowing out room temperature air. They did check the outdoor unit, said the heat pump was not operating on the outside. They then checked the breakers, said one of them was tripped. They tried to reset it, but it immediately tripped again. So we're going to drop by and take a look and hopefully not have bad news for them. It does feel like it's doing something. The line's a little cool, but can't really tell if it's cool enough. So what I noticed right away is we should not have a negative there. Basically, we are running in a vacuum on the suction side, and we do have liquid with a little bit of subcooling on the opposite side. So we are going to try to reverse this guy into heating real quick, which this one being an O unit, it reverses by powering into cool mode. So if we remove this wire, our pressures are going up on both sides. What I'm wondering is if we have either a stuck expansion valve upstairs or if we are actually low on refrigerant. So attaching our true suction, we are actually running a suction and not running it into a vacuum. We'll go check the indoor unit. Usually these Lennoxes, they will have an expansion valve on them. So if that's the case, being that we're seeing a vacuum essentially when it goes into cooling operation, go into heating, and it seems to be working okay, that would tell me most likely that we have a faulty expansion valve upstairs. The coil is in terrible shape, but there is our target. It is a bolt-on expansion valve. We did run it in cooling and in heat. In cooling, it essentially just completely restricted down and we ran into a vacuum. When we put it back in heat, it does open back up and we do get flow returning. So that kind of tells us it's not really a pre-screen or anything. It is the valve itself jammed, and then when we go in heating mode, it bypasses the other direction. So what we're planning on doing is, in order to save the refrigerant in this, we're closing down the service valve on the liquid side. Gonna partially close that one. Up here, we're gonna jump our power to our orange to make it go into AC mode, and then we're going to energize our contactor to allow the compressor to pump all the refrigerant back into the accumulator and the coil outside. That way we save it.
So I'm gonna put my gauges on before I hook it up, but
yeah, for the moment, because the valve is jammed.
Get ready. Get up there.
So you jump your orange to red to make your reversing valve switch.
Red and my orange. Let's see if I can pull this back up. Just try and get it on there. Try and get one of these on there. Okay. Now we should do a little bit of this action right here. Come on. It'll be able to get on there. What did I do? Turned on just a second ago. Wait, we got red. Oh. You gotta put it on yellow.
Alright, so crack your manifold open, because we're going to have to let it pull through, because that expansion valve is jammed so tight that it's not letting any gas through.
Okay.
We're not going to want to pump it all the way to zero because it has an older unit. It may have leaks up there, so we don't want to pull in any air if we don't have to.
Yeah.
We're getting close. So we will pull the power. Go ahead and valve that off.
First step, get comfortable. Every time.
There you go.
First try, baby. Oh. Thanks, dude. There we go.
There we go. All right, so on these little equalizers, you'll notice there's a nut right there.
Mm-hmm.
That's because this is copper and very thin right here, and it's a braze joint. So you want to have one of your wrenches on that to hold it steady while you do that, because if you twist it too hard, you can pop that seal right there. So that's why you have that little nut. But if you do break it, don't worry about it. We'll just braze it back.
Get out of there. It just sits right in there. Done one day, don't worry.
But don't be afraid to move it around a little bit if you need to, because we can cut that and see if you can pull it up.
Oh yeah. Let's see, that's probably good.
Right.
There's nothing.
Push him back in place. These always need to be pointed up, and you usually, if you're mounted horizontally, you want that one on the top. But typically, you want them mounted so that
okay. I see.
we'll put a little pressure on it, come back and check it with some bubbles.
Not that bad of a area. Try not to get it everywhere like you said before.
Just get it nice and snug in its little bed. Now I'll start our vacuum.
Aye, aye, Cap.
While this is doing this, we'll explain an expansion valve a little bit. So our liquid line runs into here. This is a pressure drop or metering device. This is attached to our suction line, and this bulb is filled with the same type of refrigerant our unit is running. So it's essentially measuring the superheat. Instead of using a thermometer, we're actually using the boiling point of the refrigerant in this bulb. So as the superheat increases, we vaporize more. As we vaporize more, it presses in on this diaphragm, which opens up the valve to let more refrigerant flow through, which drops the superheat. As the pressure drops back down, a spring in our equalizer tube, also attached to our suction, pushes the needle back closed to basically modulate the refrigerant flow. Because again, if you can imagine our A coil, we want our liquid flowing all the way up, flowing all the way down, and only completely boiling off by the very end. It's just that process of boiling throughout that's picking up all the heat inside, running in air conditioning mode, because again, we're manipulating the boiling point of the refrigerant through pressure drop devices and compressors to change the state of that refrigerant, and going from a liquid to a gas is pulling in a whole lot of heat, and then pumps back outside as a vapor, gets compressed again, runs through this outside coil, and liquefies at a higher pressure. So as it liquefies, it's giving off that heat that it just picked up.
Here you go.
It's actually holding vacuum. I'm kind of surprised. All right, if you want to go ahead and crack your liquid valve. Yeah, you open that one. We're testing it in cooling because obviously that's what we were trying to repair, but now it's 40 degrees outside. So our chart doesn't actually go far enough to tell us it only goes to 65. So we can't really measure it that from that direction. So we're showing open load for that, but honestly, as cold as we are getting a pressure here. So we are actually metering instead of being jammed completely shut. Whether or not our charge is completely correct, it's going to be real hard to tell at these temperatures right now. So I would say let's flip it over to heat and see if our charge looks good in that direction. So according to our chart, we're somewhere between two of the temperatures. It's going from 30 to 40 degrees. It's saying on the vapor side, we want somewhere approximately 39 degrees, and on that, approximately somewhere around 190 degrees, or 190 pounds, not degrees. So we are very, very close, and honestly, due to our odd temperature inside and outside right now, we can't really check the valve other than we ran it in cooling mode. We know it's actually metering because we had a pressure other than -12. So it is metering. According to our chart, we are good for heating because it is going up to the 190. So honestly, I think we're good for the day. And good job, sir.
Thank you.
So those expansion valves are basically your pressure drop devices. They do it in a few different ways. You'll have a mechanical expansion valve like that that's using refrigerant pressure and springs and diaphragms. Nowadays you see a lot of electronic expansion valves, especially in inverter type systems. The older way you used to do it was literally just a little piston that pushed forward with liquid pressure, jammed into a little seal, and it only had a little hole in it, kind of like a spray can nozzle. That was the pressure drop device. When you ran that one in the heating mode, the pressure would go the opposite direction, lock it out of position, and it would bypass around it. Those expansion valves are similar in that one direction they're modulating, the other direction they just bypass internally. Some older systems actually have a bypass with a check valve and a one-way expansion valve. That one was a two-way valve. As Jacob mentioned, there is a pre-screen on those. They can get jammed up if the system's dirty or the compressor's blown out, or who knows what may happen, any kind of debris floating in the system. This particular case, we knew that really wasn't what was going on because in our initial troubleshooting, running it in cooling, we were going into a negative pressure or vacuum on the suction side of things, and on the liquid side of things we did have pressure. When we ran it in heating, everything reversed and bypassed. We had a suction pressure, we had a liquid pressure, so we knew that it had to be going through that screen. That one we got a little lucky being that it was a Lennox. They are bolt-on for the inlet, outlet, and equalizer on them, so it's real nice. A lot of other manufacturers, they may be bolt-on one side, braze in on the other. You know, you never know what you're going to run into with them. But we got also lucky on that one, being a 2004 unit. I was actually very surprised the pressure test held, as rusty as that coil was. That held. We did a vacuumed it down. It held a vacuum. We opened our valves to let the refrigerant back in. The valve was actually modulating in air conditioning mode, but it is, looks like 34 degrees out there right now, so can't really tell what it's going to do in air conditioning mode, as our outdoor pressure was going to always be lower due to the outdoor temperature. We did run it in heating though, and according to the charging chart, we were between two of the temperatures listed, but our pressures lined up close enough in that range that I feel confident that the system is charged correctly. So we'll call that one done and find something else to do today.